What's up, guys? In this video, we're going to be talking about errors or exception handling, as well as type annotations. So all exceptions within the maci library has its own structure and naming convention. And all the third-party libraries like JSON or TOML, for example, when they throw their exceptions, they're actually all redirected and handled within the maci-specific naming convention as well. Now, the main reason why those are being redirected, as well as the reason for maci having its own exception handling process, is because maci's exceptions aims to try and provide helpful output whenever an exception is thrown. In this helpful output, it tries to provide useful and easy to understand information to quickly gather the reason for the exception being thrown. Now, the effort of this helpful output will consistently be improved or reiterated over time, but the main goal is to make dealing with exceptions very easy and make it very quick to identify the problem. Now, all of this information I'm about to dive into is explained on the documentation page under Docs, Maci, and Errors, and you'll be able to find reference material on this from there. So let's go ahead and get into an example and explain how to handle maci exceptions and understand the output that's coming at you. So we're going to use a simple example trying to load a file that doesn't exist. So let's go ahead and create a variable called file name. We'll just do game.save like that. And we'll go ahead and just do maci.load and specify our file name. Now, in this directory, we have mygame.save, but we don't have game.save. So this should throw a maci load error, and this load error is coming from the load function. Every single function in maci has its own dedicated function exception. So when I run this, we take a look down here, and you'll see maci.error.load. And so this is coming from the load function. And so we know maci is throwing a load error, and then we get our message. And here's the message. It's saying no such file or directory, game.save, and it tells you what the file is. Now, the maci exceptions will usually forward the original message that came from an underlying library or functional tool and display the message here. But if it's an exception that's specific to maci itself, you're still going to see the message here, but it's going to be a maci-specific message. And some of these exceptions have already been demonstrated from previous videos, like within the object section. But again, the main point is that you're going to see the message here, and then maci might provide some additional information down here. And some of this additional information might be attribute names, it might be line numbers, and it might just provide the actual data and show it as got. And so anytime you see got, it's saying this is what I got from you, but I'm having an issue with that. And it's going to describe the issue right above here. So hopefully that makes sense so far. But within the goal of maci, anytime you encounter an exception, the message is designed to make it pretty straightforward and easy to understand what's going on, and even provides extra helpful information to guide you and direct you to fix the problem. And as we know in the traceback, this occurred at line 5 in our code, and we can see that clearly in this traceback here. So we can easily discover what's going on within this problem. Now, the next thing I want to show you is how to handle this exception. But before we do that, I need to explain to you maci's exception path name convention. And it's honestly really straightforward. Anytime an exception is thrown in maci, maci will provide the true module path followed by the class name of the exception to keep it simple. So there is no need to import anything additional to handle it or reference other locations. In fact, maci is already showing you and telling you the path that you can write to handle it. And that path is right here. We have maci.error.load. For all of maci's exceptions, they're all broken down into 3 parts. The first part is maci itself, which is the top level module name right here. And then the second part is the submodule of maci, which contains the definitions of various errors or exception classes related to the maci module. And then we have the actual exception class name itself, which will tell you the specific exception name being raised. And in this example, it's coming from load. So with that said, let's see how we can easily handle it. Using our example, let's say that if this file doesn't exist and an exception is thrown, let's go ahead and create the file catching the exception. Now, there is many ways you can do this, This is probably not the cleanest way, but this is a way to create a file if it doesn't exist. So let's go ahead and create our try block. And we're going to try to load this file, but if this file doesn't exist, we're going to go ahead and generate the file. But now we want to specify the exact exception name path in order to catch this maci exception. And all you need to do is either write this out or simply copy and paste it. So I'm going to copy and paste it. And then using maci's dump raw function, I'm going to go ahead and create a file called file name. And I'm not going to specify any data. And that will give me an empty file. So now, if I run this, you see there's no file called game.save. But now when I run this, we see no exception was thrown. It was caught. We caught the load exception from our try block. And then we told it that if it's caught to go ahead and create a new file. And here it is. New file created. In fact, I might even add an extra piece of information. Let's see our comment here. It's just called game save data. So we'll just create the same thing. I'm going to create a string and call it game save data. Go ahead and remove that file. Run it again. And now I should create the new file with our comment with game save data in it. And that's it. That's how you handle any exception being thrown from the maci library, including the third-party ones that may be thrown. Now, to be clear, this is only going to catch the specific exception related to that specific function. So if I come in here and try to create another exception on purpose, just for example, let's say I create a file that has no name, and we'll just put in, I guess we'll put in a dictionary here, empty dictionary. If I try to run dump now with no file name path, it's actually going to throw an exception and say no such file or directory. Well, the underlying functionality doesn't allow you to create a file that has no name. But as you can see, the exception path has changed. It's no longer talking about load anymore. Now it's talking about the dump function, and specifically the dump exception class. So of course, if you wanted to handle that one, create a tuple here to capture both or multiple exceptions. And I need to change this to dump here. Then you can capture both. But I just wanted to demonstrate to you that maci truly does have different exception names for all of its functions, including the third-party ones. Now, lastly, if you wanted to capture all of maci exceptions, in other words, anything that comes from maci, you just want to catch regardless. I don't really care what exception it is from maci, just anything that maci throws at me, I just want to capture it and redirect it. You can simply use maci's base exception, which all exceptions, including the third-party ones that maci uses, derives from this base exception. And that's simply just maci.error.maci error. This is the base exception for all maci errors. In fact, if you hover over it, it should tell you that, maci base exception. So any errors thrown from maci, including the third-party ones, will be caught by this exception path, and then you can easily redirect all errors from maci accordingly. So when I run this, nothing is thrown because all errors are captured. Now, hopefully that makes sense. You might just be thinking, well, can't I just do this? And yes, you can. Or if you just type exception, you can do that as well. But it's best practice to specify your exceptions that you're capturing. That way other developers know, including yourself in the future, understand what you're trying to do. Now, this is more of a global for maci, but it at least tells developers, including yourself, that you're just wanting to capture anything inside of this try block that is coming from maci only to be captured. Because you might have other code in here from other libraries or tools that might throw their own unique exceptions, but you just want to capture maci only. This is how you would do it. Anyways, that's going to go ahead and do it for our example and explanation on maci's exceptions and how to handle them. Now let's move on to type annotations, or also closely known as type hints. Now for type annotations, this may or may not be something that you do in your code, but this is useful for those who use type checkers. If you're not sure what that is, definitely look into it. There's plenty of videos online and documentation talking about it. Now, typing for the maci data object is currently supported if needed for your type checker. Now, the static type analysis is currently being tested using maci for type safety. Updates may be made in the future for uncaught scenarios that is not passing maci or other type checkers, but for now, that's its primary testing framework. Now, all type hints from the maci library and third-party libraries within maci are accessible through the hint module to annotate unique or custom data types. They're all placed in one location, which aims to provide a simple way of finding the desired unique types you need to annotate. So just like within the exception part of this video, if you haven't seen that part, there's a path name convention which contains 3 parts, which is the module, the submodule, and the class name of the specific data type, which completes the full path to access the data type you need to hint for. So writing it out, this is how you access it. So you start with the top module, which is maci, and then we access the submodule, which is hint, which contains the definitions of the various data types, and then we access that one level further, and we have our actual class names of the specific data types. And currently there's only 4. First one being config parser, which is for the ini or any functions, if you're familiar with those. And then we have the element and element trees, which is for part of the XML API. And then of course we have our maci data object, which I'm just going to demonstrate that here, but this is where you can find all the ones that are currently unique within the whole library if you need a hint for them, and if you don't want to grab them yourself, because these actually come from the Python standard library, but they're also conveniently stored here for your easy access. Let's go ahead and use the maci data object, and if we hover over it, you can see that this is the class that will allow us to hint for the maci data object. I'll first start out creating a variable, and then create a function to show you how to annotate them. So I'm going to go variable, or var, and then I'll go ahead and specify maci.build. Now before I continue, you may have noticed a new couple folders that appeared, but I went ahead and installed a type checker, which is called maci, in a virtual environment, just so I can additionally test this out as we're doing it. But as you would expect, this function, if you know about the build, returns a maci data object, and we're actually hinting that this variable should be a maci data object. And so if we actually hover over this, we know that this is going to be a maci data object. Now technically you don't have to hint at this, and it should show that regardless, even if we take this away, and that'll still show that way. But if you have a strict type checker, it will complain about that. However, if we go back to demonstrate this using the type checker, and I believe by default it's not as strict, right now this is valid. You are explicitly hinting that this variable is going to be a maci data object and that this function is supposed to return that. So I'm going to bring in my terminal, and I'm just going to type maci main.py. And currently it's saying that there's no issues found in this file. However, if I change this to, let's say, just an integer, like a 1, and if we run this, whoops, not run this, but if we actually run maci against it, it's actually going to show you the error where there's an incompatible types in the assignment, or expression has type int, but variable is saying that it's supposed to be a maci data object. So I'm going to go ahead and fix it, bring it back to where it was, save it, now run it, and now there's no issues. So that's how you would do it with a variable, and you can actually integrate your type checker within VS Code, but I'm not going to do that in this video. You can look up on how to do that, and what will happen is you'll get these squiggly lines in red, but that's how you do it for a variable. So let's go ahead and do it for a function. So I'm going to go ahead and drop this down here. I'm going to create a function. We'll just do fn, and we'll just type in data. This accepts a maci.hint.maci data object and returns a maci hint.maci data object. And so we're just going to return data, and maybe we'll just add like a quick variable on it, for example. So we'll just add, I don't know, new var is equal to 1. We'll actually change this to maybe maci data. And so we're going to build an empty object, and then we'll go ahead and add a new attribute on it using that function. And so we'll call this function, throw in our maci data object, and then we should, at this point, be able to print the new attribute name. So if we run this, we should actually see one print. So we're actually running the code, right? And we see one print, and that works just fine. But what I'm doing is creating an empty maci data object, right? We're hinting that this is a maci data object. It's getting us an empty one back to this variable. And then we're passing our maci data object, which this function accepts a maci data object. We're adding a new attribute onto the data, right? The data object, creating a new attribute called new var, giving it the value 1, and then we're returning that maci data object, which is exactly what we're hinting. And we're not actually reassigning it to anything, which is fine because we're not trying to do that right now. It is the same object in memory that we're passing in, so we actually don't really need to return it because we're doing something in place right now. We're not returning a brand new maci data object, but I just wanted to show you this for annotation reasons. But right now, when we print our maci data object, we'll actually have access to that new attribute. Now, if we run mypi against this, there's no issues because we're correctly hinting everything. However, I'll show you what happens if we actually try to pass an incorrect data type in here. So if we pass like an integer, or actually we'll try a string this time. If we pass a string into this function and run mypi against it, it's actually going to have an error. It says the argument into your function has an incompatible type, which is string, and expected a maci data object. So that's very problematic already. So if we go back to our maci data object, that's fine. But let's say we actually wanted to capture what was being returned from this function. So let's just say like new data, for example. Now, mypi is not strict, so this should still be acceptable if I did this, and it is. However, if I tried to annotate that an integer is coming back, right, we're telling this variable that an integer is coming back, but this function actually returns a maci data object, and if we run this, then mypi is going to complain. It says incompatible types in assignment, expression has type maci data object, but variable is saying that it's being declared as an integer. So in order to get this back correctly, of course, we just need to do this, just like you would do with this, because this is just a function returning a maci data object, and this is a function returning a maci data object. And so now if I run this, we shouldn't have any issues. Now this would also work if we actually hinted, like let's say a list was coming back in our function, but the variable is stating that it's looking for a maci data object, and this function is now saying that it returns a list. So same thing, of course, if you run the code, there's no issues, but if you run the type checker, it's going to have an issue. And it's actually pointing out two issues. It's actually saying like, hey, your function is supposed to be returning a list, right? But it says that it's returning a maci data object because it is returning a maci data object, right? But it's supposed to be returning a list. And then it's actually telling you, hey, your variable is supposed to be a maci data object, but it's actually getting a list. And that's a problem. So this is kind of giving a little lesson on type checking as well, using mypi at least. And there's all kinds of settings you can use in mypi to create a very strict check or a more loose check depending on what you want. The main point of this section is to show you how to annotate the maci data object and any other objects that you need within the maci library. So of course, just go back to the way it was. We run it and we have no issues. But that's going to go ahead and wrap up this video on exceptions and type annotations. Hopefully it makes sense to you, and I'd like to thank you for watching. Take care.